Leah here from LeahFirstSci.com, and in this video I will show you how to name epoxides. Epoxides are also known as oxirane, and this refers to a molecule that has two carbons bound to an oxygen, forming a heterocyclic compound, where hetero implies that you have a non-carbon atom in your ring. There are two ways to name epoxides, both of which may show up in your organic chemistry course, and so I will show you how to use both methods. The first one is to use the prefix epoxy when following the IUPAC rule or my puzzle piece approach to naming, and the second one is to use the suffix oxirane at the end of your molecule. We'll start with a standard epoxide, drawing out the two carbons and oxygens in a ring. Using my puzzle piece approach, we'll start by identifying and highlighting the parent chain. I have two carbons in my parent chain giving me a first name of F. I have only single bonds giving me a last name of A. And I have the epoxy group showing up attached to both carbons 1 and 2, and so I get the prefix 1, 2 epoxy. Putting the name together, I get 1,2-epoxyethane. Using the oxirane method, given that there is nothing coming off of this epoxide, we can simply call this oxirane. Now let's look at a substituted epoxide. For the IUPAC rules, I still identify and highlight my parent chain, in this case numbering so that the epoxide gets the lowest number, meaning I start from the right. Having a total of 3 carbons in my parent chain gives me a first name of prop. Having only single bonds gives me a last name of ane. Once again, the oxygen is bound to carbons 1 and 2, giving me 1,2-epoxy. This gives me a final name of 1,2-epoxypropane. When using the oxirane method, I identify the entire epoxide as the parent chain and simply call it oxirane. Since I have a methyl substituent, I simply throw the word methyl in front of oxirane. Since I only have an option to connect methyl to one or the other carbon, I don't have to specify which one, and give it a final name of methyl oxirane. Let's look at an even more substituted example. Starting with the IUPAC system, I highlight and identify my longest carbon chain. If I number from the left, I hit epoxide at 2. If I number from the right, I also hit the epoxide at 2, but that methyl group gets the lower number. And so I number from the right. 4 carbons gives me a first name of but, only single bonds gives me a last name of ane. The oxygen is fused to carbons 2 and 3, giving me 2,3-epoxy, and the methyl on carbon 2 gives me 2-methyl. Since E goes before M, I have 2,3-epoxy 2-methylbutane. Now let's look at the same structure using the oxirane method. In this case, I have multiple substituents, so I do have to number the ring. You have a unique numbering system where oxygen gets the number 1, number 2 is going to be the more substituted or higher priority substituted carbon of the oxirane, and then 3 is the second carbon in the ring. In this case, I have 3 methyl groups, 2 coming off of carbon 2 and 1 coming off of carbon 3. That gives me 2,2,3-trimethyl, followed by the suffix oxirane. When you have a larger molecule with an epoxide, I recommend sticking with the epoxy method. In this case, I first identify my longest parent chain and recognize that it's the branch going down rather than just a methyl group because I have more carbons going that way. I start numbering from the left because that is where I give the lowest number to all substituents. A total of 9 carbons gives me a first name of non. Only single bonds gives me a last name of ane. I have a chlorine on carbon 1, giving me the prefix of 1-chloro. I have an epoxide on carbons 2 and 3, giving me 2,3-epoxy. And the methyl group on carbon 7, giving me 7-methyl. Arranging the substituents in alphabetical order, I have C, followed by E, followed by M, for a final name of 1-chloro 2,3-epoxy 7-methylnonane. When your epoxide shows up on a ring, you treat it the same way. In this case, the parent chain is a 6-carbon ring. 6 gives me a first name of hex, only single bonds gives me a last name of ane, and the fact that it's a ring gives me cyclo. When numbering, make sure that both carbons holding the oxygen have sequential numbers, but you can choose to go clockwise or counterclockwise. The epoxide shows up on carbons 1 and 2, giving me 1,2-epoxy. However, since there are no other substituents, the numbers are understood and I don't have to include them. This gives me a final name of epoxy cyclohexane. Are you struggling with organic chemistry? Are you looking for information to guide you through the course and help you succeed? If so, download my ebook, 10 Secrets to Acing Organic Chemistry, using the link below, or visit leahforsci.com/orgosecrets. That's ORGO secrets. For information regarding online tutoring, visit leahforsci.com/orgotutor. That's ORGO tutor. If you enjoyed this video, please give it a thumbs up and even share it with a friend or two. If you have any questions regarding this video, leave a comment below or contact me through my Facebook page at facebook.com/leahforsci. There will be many related videos posted over the course of the semester, so go ahead and click the subscribe button to ensure that you don't miss out.